Susie,
Rob.
so today you're going to tell me all about pterosaurs, is that right?
Yeah. Rob, I've forgotten the joke.
Susie,
Rob.
this week I understand you're going to tell me all about these flying reptiles, pterosaurs.
Yeah, that's right. I've got a joke for you to kick off though, Rob. Why can't we hear when pterosaurs go to the toilet?
Uh, is it because the P is silent?
No, don't be an idiot, Rob. It's because they're extinct.
Uh, so I've walked into your trap. You've got me. All
Yeah.
right, then. Welcome to the fossil files. We guarantee there'll be no more stupid jokes from this point onwards. I can't guarantee that.
No.
So, Susie, what have you been up to this week?
Um, I have been really poorly. I'm really poorly. I've got a blocked up nose. I've got a sore throat. If I sneeze halfway through this, I apologize. I've just
Oh
been
no.
miserable and sad and feeling sad for myself. How about you?
I'm okay. I won't torture you. I mean, I won't be asking you to pronounce lots of difficult foreign words this time. Then, if you can't even speak in your normal voice, I've been mostly doing not as much work as them. I've been doing lots of child activities. We've had multiple sports days, ukulele performances, levers, discos.
Ukulele.
Yes, it's been that kind of season. So fewer fossils, more time spent at the school gates with the motherland crowd. Yeah, that's what's been going on.
Well, that's nice. It's nice to have a
Yeah,
break sometimes. Is
yeah.
term finished now? You can kick
Not
back,
quite.
relax.
No, no, still going. With the students have gone home, but it's now my kids. But rather than telling you all about my family woes, let's talk about. You're going to talk to me a bit this week, aren't you? You've chosen the paper for this week.
I have. And this paper, Climate Drivers and Paleobiogeography of Lagerpetids and Early Pterosaurs. Now, I should say at this point that I get the word lagerpetids wrong all the time when I try and say it out loud.
Oh, I've
It,
already tried saying it to myself twice in preparation for this, and I was thinking, that's all right. Susie will tell me how to say it.
well, it's surprising because it starts with the word lager, which I feel both you and I
Mhm.
are quite good at saying. But when you add petids on the end, it seems really hard. I don't know why. Anyway,
Lagerpetids.
like
Okay.
Gerpetids. Anyway, this paper it is
hmm
by Davide Foffa, who is at the University of Birmingham, National Museums of Scotland, and Virginia Tech. He's very
hmm
busy, Davide,
hmm
clearly. A whole host of other authors, and the senior author is my colleague at the Natural History Museum, Paul
Indeed.
Barrett.
Indeed, it's Paul. So do we have to declare our conflict of interest here because this has got loads of our mates on this author line here?
It has got several of our mates. It is true, but that's okay, isn't it? We
That's
just have to be
okay.
careful what we say about it. But it's okay because no, they'll never listen, Rob, so it's fine.
It's true. I mean, that's going to be, if they're not listening, that's fine. I mean, they won't be, but we could just maybe point them towards. Maybe we should just watch our mouth in case word gets back to them.
M-
Are we going to pull
Maybe
our
we can
punches
find
here?
out. We can find
Yeah.
out whether any of them have ever actually listened to our podcast based on the responses that we get.
At least one of them said that he has because he promoted it. Richard Butler gave us he shouts so he's at least listened once.
He actually said we were funny.
Oh,
I know.
well, that means he didn't listen. He didn't listen. He's like, okay. So, this is published in Nature, right?
It's published in Nature Ecology and Evolution, actually, and it
Oh,
came
I see.
out in mid-June, so just a month ago or so at time of recording,
So
as
I
we are
think
now.
that's pretty. I think fossil files we're getting quite impressive with our speed. We are now bringing you right up to date with things hot off the press here. Oh, that
Yeah,
reminds me, I
absolutely.
was going to have a bit of a fossil files update. De-extinction, colossal
Yes.
biosciences, our old friends, they're back at it after you and I talked about how de-extinction was a scam. Turns out not everyone was listening because they're going to go and do it with a mower this time. They said they're going to do it, which is even more preposterous than doing it with dire wolf, because the mower has, which is this giant flightless bird from New Zealand. It's a good candidate for something to be brought back because the niche needs filling, and it would be an interesting, very interesting organism. And I'd love to see a mower walking around the forests, whatever forests are left in New Zealand. Because again, this is the other problem: there aren't that many forests left. We need to actually create the environment. But there's this massive distant evolutionary history between the moa and its closest living relative, which is, I think, a tinamou, if I remember correctly, which is this tiny
All right.
flightless thing.
Mm.
So
Yeah.
it ain't going to happen. It's just going to be a stupid looking bird.
Well, as I wrote on Blue Sky, Rob, I assume they'll just make a slightly larger pigeon. They'll take a pigeon and make a slightly larger pigeon.
Give it
Maybe
a
it will have a
Kiwi
longer
accent.
penis again. Yeah.
It'll go around saying, I was going to do a bad New Zealand accent, but that was a terrible idea. Let's not do that.
No,
Okay,
go on,
so
do it. Do it. Can
no,
you do
I'm
a
not
New
going to do
Zealand
that.
accent?
No, mainly it's based on my knowledge of Flight of the Conchords. This is my embarrassing lack of knowledge about New Zealand. Anyway, I wanted to update us on the colossal biosciences scam ongoing and how people are getting sucked into its orbit still. I guess we need to be careful about calling it a scam. Go back and listen to that episode if you want to learn more about what I think about that. But anyway,
It's a good
pterosaurs.
episode. I recommend
It,
it.
it,
I listened to
it
it and I
is.
thought we were very funny. Yeah.
As did Richard, or at least he lies about it. So pterosaurs is interesting because where they come from has always been a massive problem, right?
Well, exactly. Pterosaurs obviously are the first vertebrates to achieve powered flight. So they are these reptiles that are they're closely related to dinosaurs. They're like the cousins of the dinosaurs, and they lived alongside the dinosaurs in the Mesozoic. And they have wings that are kind of skin, they're membranes, aren't they? They're not feathered or anything like that.
Mhm.
Um, and there's various controversies about pterosaurs, everything from how they flew and whether or not their wings were attached to their ankles or halfway down their legs or other parts of their bodies and all sorts of different things. But
Whether
this
they had
paper is
integument and did they have feathers? That's another one.
good
No,
point. Yeah, integument,
yeah.
whether they had these kind of well, they have these sort of filamentous sort of
Mhm.
integument, don't they? Um, but this paper actually goes right back to the beginning of the pterosaurs and looks at um, yeah, like why, where they came from and how they first radiated, and the early evolutionary history of them, and what
Mhm.
factors in the environment might have allowed them to diversify and radiate. So yeah, as you say, Rob, the early question about pterosaurs has always been, well, where did they come from? Because they kind of appear in the fossil record fully formed, don't they?
Mhm.
We don't have sort of stem pterosaurs. There's nothing that, is like kind of halfway there with a little bit of a wing, but not a full wing. Um, so yeah, they turn up kind of fully formed. But several recent studies have suggested that this group of Triassic reptiles, the lagerpetids, are actually the closest relative. So they form a group. Pterosaurs and lagerpetids form a group called the
Mhm.
pterosauromorphs. And lagerpetids, they it makes sense. They bridge a morphological gap between something like a dinosaur and a pterosaur because they're quite small. They're about half a meter in size most, and they're two-legged. Um, they probably maybe they were insectivorous or something like that.
So, I mean, this is the reason straight away piqued my interest because I was well aware of the fact that we've got this big gap with pterosaurs. They just appear sort of fully formed. And this links back to what we were saying about plesiosaurs. Both of these things, we've got this big missing gap at the beginning. Things like birds and whales, we actually have this nice transition, but pterosaurs and bats is another one, and plesiosaurs, we don't. So this is already setting up a good problem that needs solving. When we talked about the gaps, we need to give the gap a name. But in this case, the lagerpetids, again, forgiveness for the pronunciation. I'll be honest with you, I hadn't actually come across them very much. So you described them as these, before people were aware of them as being the closest relative of pterosaurs. Did we know much about them? I mean, were they? I mean, I hadn't heard of them. Does that just plead my ignorance, or were they particularly unassuming, uncharismatic critters?
Yes, I think that's probably the latter. I think they're Triassic reptiles, and there's in the Triassic's a really interesting time period because there's a whole bunch of non-dinosaurian reptiles, both on
Mhm.
the crocodile line and on the bird line of the archosaurs, that are they're really diverse. They're doing all sorts of interesting, different things, and yeah, there's all these different reptiles that then went extinct at the end Triassic mass extinction, as the lagerpetids did. And so I think before they were recognized as a group, as sister taxon to the pterosaurs, they were thought to be, closely related. They were thought to be one of these kind of, lineages that branched off and shared a common ancestor with the pterosaurs and dinosaurs. But it wasn't until more recently that they were recognized as the sister taxon. And actually, a lot of them are relatively recently known about. So I was looking at some of the names of the taxa in these papers. So there's these ones which again, why do they call Dromomeron romeri? I
I
remember
did
that one
make you say
being
that one. That was you chose to say that
I
time.
chose
No,
that I did. I remember that one being described. I think that was described by Sterling Nesbitt, who is an author on this paper. But Dromomeron romeri. I mean, come on, guys. Really? Anyway, so I think they're relatively, a lot of them are relatively recently recognized, and that's probably helped in the fact that the more data we have, it's the easier to fit them in a phylogenetic
Mhm.
tree, isn't it?
So whilst you were talking, I was just looking them up to do my, this is the great way. I should read Wikipedia whilst you're talking to catch myself. But I'm now realizing that they mostly, as you said, have been discovered recently, but most of the discoveries have been after 2010. So I'm now old enough to think that if I haven't heard of a particular fossil group that I didn't even learn about during my undergraduate or postgraduate days, this is just, I am now so old that this is the newfangled fossils coming along and getting described. I can't keep up. So everyone
All
just
these
keep them in the ground.
newfangled Triassic clades.
These newfangled Triassic things. Anyway, as you were. So that's the context. We've got these close relatives to the pterosaurs.
Yeah. Okay. Um, and actually, when you look at the fossil record of these two different uh, groups, the pterosaurs and their sister taxa, the lagerpetids, if you look at it through time and space, which the authors show in figure one, Rob, of this paper, then we can see some interesting things. So, do you want to describe the maps in figure one here? What we've got going on?
Yeah, sure. So, I mean, I don't, people don't need to look at these figures whilst we're telling them. I mean, it's a fairly straightforward picture. We've got in the middle Triassic, we've got these lagerpetids. They are distributed across South America and bits of Europe and Asia. And then moving up into the late Triassic, still mostly now with lagerpetids, but in North America, South America. And then they basically just mapped the distribution of these things through time. Now, there's not a lot of them, one should point out, right? You could probably name each one of them in this podcast, or we wouldn't be able to pronounce them, but we could name all of these taxa. And then but when we get into the later Triassic, the pterosaurs turn up, and they are quite concentrated initially in one particular place. It looks like Europe, as far as I can tell. And then as time goes on, those pterosaurs sort of spread out across the world. Maybe. Well, I guess that's why they need to do all these fancy analyses to figure out where and how they were going places.
Interesting point. Um, do you know what so I like this figure. Do you know one thing that really annoys me though about it?
Did
Have you
they
spotted
misspell
it?
fossil again, like in the Neanderthal one?
No, but they've missed the capital on Triassic down the side and the time scale.
Oh
Look at that.
no.
Oh dear.
Oh God. I'm gonna have to, if I ever get you as a reviewer, you're gonna be maybe I should get you as a reviewer because you'll be
Maybe you
eagle-eyed.
should.
Yeah,
Maybe you should.
you've
Anyway,
got the attention to detail that one needs.
it's the first thing that caught my attention was the lack of capitalization of Triassic in this figure. Anyway, it's a bit of feedback, Davide, if you're out there. Um, anyway, yeah, so I think a thing that is important to say is what the continents look like at this time, right? Because everything's
Oh
together
yeah.
in all the continents are together in a single landmass called Pangaea. And so, yeah, all continents are from stretching effectively from the North Pole to the South Pole. And there's this kind of big sort of triangular shaped bite out of the eastern margin of Pangaea, which is the Tethys Sea. And this is a big, long-lived seaway that is important for reasons that we'll see. Um,
Okay.
But yeah, so if we look at this distribution of pterosaurs, as Rob said, I mean, the first thing that we should notice is that the lagerpetids are actually known from much older rocks. So they're known from the Middle Triassic, whereas we don't see the earliest pterosaurs until the Late Triassic. But of course, if they are in fact sister taxa, then the pterosaurs must have been around in the Middle Triassic. We just haven't found their fossils yet, or maybe we have and we just haven't recognized their fossils yet.
Hmm. It
But
implies a gap, yeah.
yeah, we should name it Unwin's Gap.
Foffa's or
Foffa's Gap.
Foffa's gap. That sounds wrong.
Anyway, and then as we get up into the Norian, then we start to see the first pterosaurs. But also, actually, when you look at their geographic distribution, their distribution in space, um, they do overlap a little bit in North America, these two, but
Hmm.
actually they're in different sorts of rocks. So the lagerpetids are found in rocks deposited by rivers and on floodplains. They're widespread across this broad latitudinal area, as you noted. We have some right down in the south of Pangaea, some right in the north of Pangaea, whereas the pterosaurs, in contrast, are actually they're found over a much more restricted latitudinal range. So primarily in the tropics, as you noted, around in what is today Europe, but of course with that Europe was in the tropics at the time, and also mostly in marine rocks. So there's a sort of indication here that they might have inhabited different environments, these two groups, though they might have had
Hmm.
different sort of climatic tolerances. Um, and the authors say that this is interesting. Because it could help us to understand what survived the end Triassic mass extinction. Because as I said earlier, of course, lagerpetids went extinct at the end of the Triassic period, whereas pterosaurs went on to radiate through the Mesozoic, right, and lived right up until the late Cretaceous, didn't they? And it's evolved into some of those absolutely gigantic things like Quetzalcoatlus, more fun pterosaur names.
Hmm.
Um, so pterosaurs very successful, made it across the end Triassic. Lagerpetids not so much. So is it something about these environmental preferences or
Hmm.
tolerances that could tell us something about survivability of mass extinctions? And of course, that's an interesting question, and I think it's one that we've touched on before. Is
Hmm.
why did some things go extinct and not others?
Hmm.
Um, and is there something here that we can look at?
Hmm.
Um, so the reason I wanted to do this paper, Robert, was because the papers that we've done so far have mostly been about actual fossil specimens, haven't they? I
Hmm.
mean, whether they are, well, fossil is sometimes debatable, subfossil,
Fossil topsoil. Hmm.
topsoil, but actual specimens. But actually, of course, the other side of what we do as paleontologists is we do take sort of big data sets um, that are built out of all of those individual fossil finds and try to do big analyses to understand how biodiversity has changed through time. And that's kind of, I guess, the fundamental tenet of what we're trying to do as paleobiologists. And so all of those individual specimens are the building blocks to allow bigger studies to be done. And this is kind of one of those bigger studies. So it's not specimen focused. It's focused on that sort of data instead. So it's a different sort of paper, I think.
Hmm.
Um, okay, so what did they do to try to get to the bottom of figuring out whether pterosaurs and lagerpetids really did have different climatic and environmental requirements, or whether this is just some sort of, thing of the fossil record, some sort of bias in the fossil record? Um, well, I am not going to go into the methods in a lot of detail here, Rob, because they are, it's fair to say, long and dense.
Well, I'm kind of relieved, but I'm kind of disappointed.
They use general circulation models or a general circulation model. So that's a climate model. And they also have a series of paleogeographic reconstructions from the Triassic through the Triassic. Um, so the Triassic's super long. We always forget this, right? But it's really, really long. And so you need to think about how paleogeography, how the landmass, the shape of the land was changing through the Triassic period. And so they've modeled about 40 million years here, I think, of the Middle and Late Triassic. And what you can do is then they take these different paleogeographic time slices or maps for each time slice and apply their general circulation model, which models looks at the distribution of the oceans and of the continents and figures out what the climate would have been on the continents as a consequence of that particular arrangement of oceans and continents and that sort of thing. And so they can reconstruct climate on Pangaea. So what they did was they reconstructed Triassic climates. Um, Using this general circulation model. And they used a variety of multivariate statistics to look at climate variables where pterosaurs and lagerpetids lived. Um, and this they sort of use this as it says ecological niche modeling. They sort of used it as a like training data set. So they said, okay, well this is the climate in which we see these two different groups living. Now, where else do we see that climate on Pangaea? And they
Hmm.
look and they can say, okay, well, we don't have a fossil record in that area at the moment, but presumably the pterosaurs and the lagerpetids could have lived in that area. So it's
Hmm.
kind of a way of making up for missing data in the fossil record, so fossil record biases. So it's an interesting approach. I have some
Hmm.
reservations, but it's an interesting approach. So anyway, they did this, and they also, yeah, they did some statistical and some phylogenetic work around, yeah, areas of origin and also dispersal.
Hmm.
So the first thing that they found was that pterosauromorphs, the lagerpetids plus the pterosaurs, originated in South America, or what is today South America. Well, whereas the pterosaurs themselves originated somewhere around the tropics of the Northern Hemisphere. Now, I don't think that blew anyone's mind. I think, if you just looked at a cladogram, that's the conclusion you'd come to. I'm not sure that paleobiogeography model was necessary to figure that out, but anyway, there we have it. Um, so they then did some work on dispersal and they looked at how easy it was for these different groups to disperse across various climatic barriers throughout the Triassic. And they also compared them a little bit with dinosaurs, which of course they're closest relatives. So they use these two different methods, and I'm not going to get into the two different methods because I really didn't understand them, and I don't want to pretend I know something about something I don't know anything about. But the what came out of it was that there were barriers to dispersal for the both the pterosaurs and the lagerpetids. Not as and these they seem to be greater than for the dinosaurs. Um, but there was some dispersal throughout the Triassic, and actually it became more difficult to disperse through the Triassic. And this is interesting, I think, because when you look at Pangaea, well, Pangaea is this big supercontinent, and as I said, it extends from the poles to the equator, from the pole to pole, right the way across the equator. And when we look at Triassic rocks, they're always desert rocks. They're often, anywhere where you go in the world, Triassic rocks are like red and deposited on land, deposited in sand dunes. It's really characteristic of the Triassic. If you've ever been down to, have you been down to Devon? Have you been down to the area like Seaton?
I have, yeah, but my grandmother was from there, but also the bits closer to me, on the Wirral, where we've got these very characteristic
Okay.
Triassic red beds. Yeah, yeah.
Yeah, so really classic Triassic exposures are, you know, thought to be very characteristic of what the environment in the center of Pangaea was like. It was a huge continent, and of course, continental interiors are often deserts. So it has been, suggested in the past that there was this kind of desert belt really that was almost, impenetrable, and that things weren't able to disperse across it. And when we look at their um, climate maps, they do have areas where you've got kind of this bit in the middle, particularly earlier on in the middle Triassic, where it doesn't look like it was suitable for anything to be living, and that's probably presumably because it was too hot.
Mm.
So maybe the barrier, but well, it's a little bit surprising then that the barriers to dispersal seem to increase throughout the Triassic as
Mm.
into the Retian, we know that everything got a bit cooler and we lose those desert rocks. But anyway, that's what they found. And then they used a different method. And that showed a slightly different picture where they found, um, for pterosaurs at least, there was a big leap in dispersal. And their ability to disperse in the mid-Norian, and they sort of put this down to maybe pterosaurs actually being starting to be really good at flying. But I think skipping over the dispersal stuff, I think what's more interesting is the paleoclimate niche occupation stuff.
Yes.
Um, because what they find is that when they look at the sort of where these animals are living, um, they find that there's a statistical difference between the sorts of environments that they like to inhabit. So lagerpetids liked warmer, drier areas with little seasonal variation in temperature, while pterosaurs liked much cooler, more seasonal areas. And actually, lagerpetids moved into warmer, drier, and less seasonal areas throughout their evolutionary history. And as a consequence of this, it means that they could have occupied a much broader latitudinal range. They had much higher thermal tolerances. And of course, this is very important in this very hot Triassic world, you'd think. So when the authors then sort of used that information from the fossils themselves to look at where they might have lived if we had a perfect fossil record, what they found was that there were broad areas of Pangaea that were super suitable for the lagerpetids. And actually, if you look at the maps, it seems that their range might have increased from the Ladinian in the later part of the middle Triassic, right the way through to the latest late Triassic. By the
Hmm.
Retian, it looks like they could almost live anywhere. They could live across the whole of Pangaea. So they clearly had very broad thermal tolerances, and were very widespread. There were very few barriers, by the looks of things, to them being able to disperse across Pangaea.
So why didn't they then?
Well, that's a good question. I mean, I guess there's a number of different options. They did, and we just haven't got their fossil record, so they're just not well
Hmm.
enough preserved.
Yep.
Um, Maybe they did, and well, either the rocks aren't preserved, or the
Hmm.
fossils aren't preserved,
Yep.
or they're wrong, and this data's all rubbish.
Well, given that it's our friends, we probably should say it's either the first one or the second one, but not the third one. Okay, it couldn't possibly be the third one.
Couldn't possibly
Not
be the
not for
third.
these guys. No.
I mean, it's a model, isn't it? So,
Yes, yeah, 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 yeah. But I guess
um,
the more important model, I guess, was when it comes to the pterosaurs, because that's the one where there's this big question mark.
well, the pterosaurs are interesting, aren't they? So the pterosaurs,
Yeah.
they find a rather different story, and the pterosaurs. are have much more restricted requirements in terms of their climate. So, as we said, they preferred much more seasonal, much cooler and wetter environments, and they were restricted really to the shores of Tethys.
Hmm.
And actually, uh, it looks like from their climate suitability maps, had pterosaurs been around in the Ladinian and Carnian, they would have actually quite enjoyed it because there were some areas to the southeast of Pangaea which looked like they were quite suitable for them. But as we get through the Triassic and particularly into the time when we actually have their fossil records, um, they're really restricted to areas around kind of the southwestern margin of Tethys. Um, there are patches all around where they might have been able to live, but obviously they would have had to disperse across uh, places when they wouldn't have been able to live. So they had a very patchy geographic distribution.
Hmm.
Um, and maybe there's something about this dispersal event in the Norian that they saw in their dispersal data that talks to this. So anyway, what does this all mean? Well, it indicates that pterosaurs and lagerpetids had very distinct and divergent dispersal histories during their evolution. Obviously, lagerpetids achieved this very wide latitudinal distribution soon after they appeared. They were able to be present at high and low latitudes. They had a broad tolerance of different climatic conditions. They had high thermal tolerances. Pterosaurs, however, originated in low latitude coastal regions, very specific requirements. There were habitable areas, but not really in the continental interiors. Because they could fly, they would be able to get between them. But they also say it's possible that early in the pterosaur evolutionary history, they might have been restricted to living in trees and in forested areas, and this could have also prevented them from being able to kind of disperse into other parts of Pangaea
Hmm.
as well. And I think this is weird, right? Because pterosaurs survived the end Triassic mass extinction, but lagerpetids didn't. So I guess going back to the why is this interesting question here? We're talking, talking about survivability. Um, I think we might have given those if you looked at those maps and said which one of these things is going to survive a mass extinction where you've got huge volcanic
Hmm.
eruptions and climate change and all this stuff's getting warmer, you might have hedged your bets with the lagerpetids, wouldn't you?
Potentially, but how much of this is to do with things that we can't measure in these sorts of analyses, like ecology? Like, are these pterosaurs warm-blooded by this point? I mean, do we have an expectation that pterosaurs are warm-blooded? I mean, powered flight is quite energy rich. I'm talking about pterosaurs in a way I don't know about them. Do you have any idea? That would make a big
Well,
difference about whether you're going to survive a mass extinction, I assume.
I mean, pterosaurs had an eight. Well, they had skeletal pneumaticity, right? So they have an avian style lung.
Hmm.
So which is usually considered to enable very high metabolic rates. So, and as you say, they have powered flight, which also requires high metabolic rates. So they probably were, endothermic, high metabolic rates. Yes, but I don't know about lagerpetids. I don't know whether they did as well.
Well, given what you said about there just being holes in rocks, it's unlikely. I guess we'd have that level of detail from them. But I mean, it's all part of the ecology story, right? Why does some, I mean, this is going back to our conversation that we had about the Triassic when we were talking about the poos, I guess, is that, yeah, there's an important load of things that we can measure, like the distribution of these things through time and space. We can think about their climate, we can think about their ecology, we can think about their adaptations. There are some things that we can't measure easily, like the physiology and those sorts of things, but there's also just chance, isn't there? As you emphasized last time, like what's going to happen, what's not going to happen, I don't know. Also, I guess once you can disperse, I mean, this is going back. I'm now thinking back to my fish that I did in the early noughties. Right, one of the reasons that we put forward for the fish that I was looking at maybe going extinct is because they couldn't disperse. Right, they were very limited in their ability to escape their little. They lived in a very narrow environment, which was these freshwater environments. And as the sea levels rose and fall during the Devonian, because they couldn't disperse very far, they died. Whereas the ocean-going marine ones, they could just swim across the entire planet and survive. Same thing with the pterosaurs, right? I mean, this is a massive oversimplification, but if you're a pterosaur living on the sea of the Tethys in the late Triassic, you don't like the conditions, get up and leave. You can move, right? You can go anywhere you want, and you can move with the changing conditions. You can disperse. You have that ability. If you are a lagerpetid, you're shit out of luck. You are just gonna have to stay in that little island and die.
Yeah, exactly. And I think, that's something that they talk about actually is that maybe it was this, key innovation of pterosaurs to be able to fly that allowed them to survive the mass extinction.
Mm.
But I mean, like, you don't really get that message from the paper, do you? Because although, you said that the lagerpetids, if they would be shit out of luck, but actually looks like their environment was everywhere. I mean, I guess it'd be
Mm.
interesting to know if you could do a climate model of actually, the 100 years or however long the M Triassic mass extinction, the peak of the M Triassic mass
Hmm.
extinction, what was the environment like then? And
Yes.
you know, when you've like doubled carbon dioxide in the atmosphere or quadrupled it or whatever, what effect did that have on these
Mm.
kind of survivability maps? And do you see then that the lagerpetids are, their climate suitability has completely disappeared and they're nowhere, whereas maybe there's still some coastal areas where pterosaurs could still inhabit or something. I mean, who knows? But yeah, but they haven't done that. So, but I think it's a really good point. Like the answer isn't in looking just at one thing, is it? Because
Mm.
how biodiversity is shaped by through time is not just around environment, but also,
Yeah.
as you say, around ecology, but also through biotic interactions between with
Okay.
different animals, and it's difficult to model all of these things in one go. But this is one
Absolutely.
one picture of one piece of the puzzle, no?
So I think one of the cool things that I wanted to ask you about, I guess maybe I'm interrupting you, you haven't got to that point yet, was about the towards the end they start using these climate models to make predictions, right? About where we maybe could fill in these gaps. Where could we go and find the right rocks that would be preserving them? And I guess my attention was particularly drawn to the fact that they said maybe it shouldn't be Kyrgyzstan, where you've been off doing field work. Maybe instead we need to be going to the USA in a more comfortable environment. I don't know. Does this change? Does this paper change where you might be going digging up your rocks now?
Well, the stuff that I'm looking at is Middle Jurassic, so it's
Oh, okay,
slightly
so definitely
different,
not then.
slightly
Completely
different.
irrelevant. Yeah,
But I mean, it's a cool way of doing it, right? So what
yeah.
they say at the end, of course, is actually why aren't we finding the pterosaurs? So that end section is focused on why aren't we finding the pterosaurs in this earlier part of the late Triassic and middle Triassic, where we know they must be there,
Mhm.
but we just haven't found them yet. And they say, well, maybe it's because we're simply not preserving their fossils, but actually we have a load of lagerstätte, so areas of where we have exceptional fossil preservation, where we actually find animals that are not that dissimilar to pterosaurs in terms of their preservation potential. So things that might be quite small, quite flat, often preserve in, maybe shales or lake environments or something like that. And they've got loads of those. We've got loads of those at this time period. So why, if surely we would see pterosaurs if they were there. But then what they do is they go and look at where those lagerstätte are and say, well, actually, they occur in areas where pterosaurs probably weren't living. They were probably
Well,
unsuitable
this
for.
raises a question for me that I've been interested in this idea about using predictions to make,
Mm,
go and dig up the right kind of rocks. But the different conversations I've had with Jane, erstwhile supporter of the fossil files, Jane Reeves, who works behind the scenes and doesn't want to be on thing. Anyway, um, we've been trying to work on this sort of problem, but how do you detach ecology from taphonomy? Like, if you when I was talking about taphonomy, I'm talking about the likelihood of you getting preserved as possible. We've mentioned forests, we've mentioned marine environments, we've mentioned rivers, and deserts. All of these things have very different ecologies, but those ecologies are very much intertwined with the types of preservation that will take place. Maybe if you're a pterosaur or a your beer drinking lager animal, then you're fine because you're the same sort of taphonomy, maybe. But I guess that's a big problem there. We don't actually know how to answer that.
yeah, absolutely. I mean, I guess that there is a solution where you go look, and after a certain amount of time, if you don't find something, then the conclusion has to be it's probably not there.
Yes.
But there's
How
got to
many
be quite
field
a lot of
seasons
looking.
before you give up? Yeah.
Yeah, 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 exactly. But I mean, there are certain places where you think, we've been digging here, we've been looking for dinosaurs or for fossils or whatever here for
Mm.
150 years, and no one's ever found X. Then maybe that's because if
Yeah.
X was there, we would have found it by now. Surely we would have
Yeah.
found it by now. But yeah, I don't know. I mean, having said that, don't we think that only about 1% of all animals that ever lived got fossilized? So probably we
Hmm.
won't ever find 99% of the life that actually lived
No.
ever at any one time period.
Boo. Cry.
But then, I mean, no, I did. I actually, I think I really liked about this paper was that
Mm.
they, this using the niche modeling as a way to think about where we should be looking in the future for this kind of missing fossil record. Unwin's Gap.
I like this paper too. I mean, I guess I'm obliged to say that, but also I did actually like it. Do you know who didn't like it?
Who didn't like it?
Reviewer
The
number two.
reviewers?
Reviewer number
Ah,
two.
do we
So
do we have the reviews? I didn't see the review.
I've looked up the reviews. I don't know if this is unkind. Reviewer number one liked it. Reviewer number three liked it. Shall I read you out what reviewer number two said?
Yeah, I really want to know. I bet I know who it is as well. Go on, hit me.
Um, maybe this is unfair to the authors, but this okay to give people a bit of peek behind the scenes. Some journals now have started sharing all the peer. So Susie described the process of peer review a few episodes ago, where every manuscript is sent to another experts, a series of experts to have a look at this particular paper. And now that used to be done behind closed doors, but now that it's being shared more frequently. So reviewer number two, described as macroevolutionary methods and phylogenetics person. Oh, I've lost their comment. Dear editor, blah, blah, blah. The very premise of this paper is not remotely interesting. That's a savage open, isn't it? Blimey. Pterosaurs were flying vertebrates, whereas lagerpetids were small cursorial animals. Of course, they occupy different niches. The author's setup would be akin to asking if mice and bats partitioned into different roles. The authors do not demonstrate that the results are not an artifact of sampling and record bias, fossil record biases, a known confounder in paleobiological studies. They do not include any sort of sampling bias metrics, blah, blah, blah. They go on, and they start being quite scathing. But
They
the
start being. I mean, I would say from
that
the first line, it's quite scathing. Wow.
but the authors are able to give a response to that, explaining why that's not quite the case. And review number one and review number three felt very differently. So on balance, is out there. I guess that was just a peek under the hood of what goes on there.
Yeah,
Um,
interesting. Is the is the author's responses published as well?
yes, it is, and I it's right down the bottom, but it's far less interesting. But they were able to swat this away as a concern, I guess. Here's a question for you. This is a very technical phylogeny question. Um, so they used a phylogeny that has an evolutionary tree, I should say, which is important for this because they're looking at paleobiogeography, moving through time, and they're using it to make predictions. So you need an evolutionary tree, right? We love evolutionary trees on the fossil files.
We do.
Um, they used a phylogeny from a paper from 2023. Great, lovely. After this paper was submitted, a new phylogeny for lagerpetids and pterosaurs came out. Um, so this is completely unfair on the authors to lay this at their feet because that came out after they've done it. And this happens to all of us. So this new phylogeny, as you talked about in your intro, lagerpetids and pterosaurs are sisters, right? They are the closest relative of each other. Fine, lovely. And it used to be the case that lagerpetids were a group and pterosaurs were a group. This new phylogeny finds that lagerpetids are paraphyletic. So that
Paraphyletic
means that
assemblage in basal tip, yeah.
yeah. So that actually is really important when we think about the lineages, because rather than them being two groups that are closely related, instead it's more the case that one is sort of, I wouldn't say ancestor, but more like a group from which the other one was derived from within rather than outside of it, which implies quite a different thing
Yeah,
for the origins of fossil record.
it implies a completely different story for this entire paper. But any phylogeny is only ever a hypothesis based on the data that's available at the time and
Absolutely,
the
absolutely.
characters that you sample. So, I mean, what I guess is that they could. So in terms of the absolute story, obviously it does matter in terms of where pterosaurs come from, because
Hmm.
now they're coming from. If that phylogeny is correct, they're coming from within lagerpetids effectively. So that explains
Hmm.
why we don't have early pterosaurs. It doesn't probably change the climate story, right?
No, the climate story should be
The,
completely unaffected because that's
yeah,
based on the distribution of them in space. It's not based on their evolutionary relationships, as far as
it's
I
not based
understood
on their
it.
evolutionary relationships at all.
No, no, no.
The only thing that is based on the evolutionary relationships is their biogeography and
Yes.
the dispersal story,
Hmm.
which I don't feel they really dwelled on. I felt like that dispersal story, in this
Hmm.
paper. But there's lots of different authors on this paper, and I felt like one of them did that bit, and then some others did another bit, and then they just sort of
Yeah,
slotted it together, and I'm not quite sure how that fitted in with the rest of it. But
yeah.
yeah, I mean, it does change. It just you're absolutely right. It does change that kind of picture of them being sister taxa. But what's to say one's right and one's wrong at this point? I mean, they're just any
Mm.
analysis is just it's just a hypothesis, isn't it? And just because it's more recent doesn't make it better, I guess.
No, indeed. Um, I guess I just wanted to float that out there. And also these things happen, right? I guess you could rerun the analysis with the new phylogeny. I don't know how much work that would be. Hopefully not too much. But again, all that climate stuff is going to still remain the same. But
Yeah,
it might change the way you might make the predictions about where the pterosaur missing ancestors may be.
absolutely. Well, there wouldn't be any, would there? Because you found them. They're the
Yeah.
lagerpetids. So that's,
There's still a
that
big
explains
morphological
it.
gap. Yeah, there's a big morphological gap
Yeah,
out
yeah,
there somewhere. Yeah.
yeah, yeah. It's true.
Cool. Well, thanks for suggesting this paper. When you first suggested this paper, I sort of sighed because I thought, oh, it's going to be loads of modeling. But actually, there's some really interesting thoughts there about big questions about paleontology, missing gaps, where these things were evolving, how they're evolving. I like it.
Good.
So, what do you think the take-home message is?
Um, I think that there's a take-home message around mass extinctions again. I think that
Mhm.
the things that we might predict to just because something was widespread and apparently had excellent thermal tolerances and it still went extinct. And so maybe there's still the chance. Maybe we're still back to that thing about what survives a mass extinction. We haven't figured it out yet, and is there a big dollop of chance involved in what survives a mass
Mhm.
extinction? But I think your point was also very, very good, which is that we're only getting at one part of the story here. We're only getting at the environmental requirements and not at ecology and interactions between species and things like that as well. So there's
Mhm.
that's a fair point. And is it just that they could fly away? That's
Well,
it.
wasn't using that as a criticism, more just the case that that's another part of the story. I mean, what they've done is still, you know, really helpful, especially with respect to the making predictions. I think I'd like
Mm,
to see more people doing that sort of thing.
yeah,
Tell us where to go and dig things up, and we'll go.
yeah.
Yeah,
Well, also pay for us to do that too.
yeah. We're gonna go and fill in the Unwin Foffa gap in New Mexico, and can I please have a grant to do so? Yes.
Yeah, yeah. And I want to
Yeah.
stay in a ranch house and not
Yes.
camping.
Oh, yes, yes.
Christ.
I mean, well, that's interesting you say that because I always thought I was on my field work in Mongolia. I think my geological friends were a bit annoyed with me for being a bit biologically soft, like, oh, it's raining, I don't want to stay in my door. Whereas you don't. I wasn't a massive fan of the camping. Uh,
I had a lovely time in Mongolia. My tent was very, very nice, I have to say. I had a bed, I had a mirror, a towel rail. It was brilliant.
what?
Yeah.
What is going on here? Oh my God. Yeah, my experience was not the same. Thanks, Susie. I enjoyed that paper. Next week is it me choosing something? Do you want to learn
Yeah,
about some early vertebrates?
sure. Let's do that. That sounds good.
We still haven't done any invertebrates. I'll have to find you an invertebrate somewhere.
Yeah.
Do you want an
Well,
early vertebrate?
let's just see if we can find an invertebrate paper.
Okay, all right. And then I'll see you next time, Fossil File fans.
See you next time.
The Fossil Files was presented by Robert Sansom and Susanna Maidment. You can find more information, including links to the original papers that were discussed, at fossils.libsyn.com, and you can contact us at fossilfiles.pod@gmail.com.